So far in the videos prior to this, we've been using different methods like the Plurality Method, Boorda Method, Plurality Elimination Method, and the Pairwise Method to try to find the first place candidate in elections. And normally that's what we're worried about. We're worried about the person in first place. But there can be contexts where we're worried about who gets first, who gets second, who gets third, who gets fourth. So possible context is here. Let's say this data here is not for a presidential election or a political election. It's for a game show. So we have 4 contestants, A, B, C, and D. And at some stage in this game show, the audience of 42 people is asked to vote for their favorite contestant, and furthermore they're asked to rank them first, second, third, and fourth. And whichever contestant gets first gets $50, whichever gets second gets $30, third place gets $20, and let's say last place gets $10. So it's important who gets first, second, third, or fourth, because that's how you decide who gets how much money. So this is going to be called different kinds of ranking methods. On this side of the page we'll be talking about normal ranking methods. On the opposite side of the page we'll be talking about recursive ranking methods, which are a little bit different. So nonetheless, they are both types of methods used to not only find the first place person in some election or competition, but also find the second, third, and fourth, and so on places as well. So we'll just talk about each one as it applies to each different method we talked about. So first method we talked about was the plurality method. Even though it's flawed, we can still talk about how we can use it to find the first, second, third, and fourth. So this is probably the easiest one. So if we have our 4 contestants, A, B, C, and D, we can easily just count how many first place votes each person got. Remember, the plurality method doesn't really care about anything below the first line. So A got how many first place votes? He got 15. B got how many first place votes? 5. C got how many? It's going to be 11 and 2, so 13. And D gets how many? 9. So now, using these, it's pretty easy to see how using the plurality method, we'll just see who gets the first, second, third, and fourth. So first, second, third, fourth. First will just be the person with the most votes, so A. Second will be the person with the second most votes, or C. And then the next one will be D, and the last one will be B. So each time we find a ranking, we'll put it in a red box to identify that that's the ranking under that method. So under the plurality method, we have A is first, C is second, D is third, and B is fourth. So now let's look at another method. The next method we talked about was the Boorda method, where we calculated the Boorda points and we awarded the first place person as first place. So it's just a logical extension of this. We see that since B got the most Boorda points, just beating out C by 1 point, B is first. So we have first, second, third, fourth. So the person with the most Boorda points gets first. So we have B here. Then the person who has the next most Boorda points, C. Then we have the third will be the person with the next most, D. And since A has the least, he is put down here. So already we have something weird emerging. We have, let me put this in red. We have something weird emerging. We have A being fourth here, but where was he placed under the plurality method? He was placed first. So we already have some dichotomy between the different methods. So the next ranking method we'll talk about is the normal plurality elimination method. So now in this method, remember, we eliminated one person, then we took them out of the list, then we eliminated the next person with the least votes, then we eliminated the next person, and so on. Till the last person left was the person who won. So let's say B got out first. That would put him in 4th place. C got out next. That puts him in 3rd place. A got out next. That puts him in 2nd place. And therefore D won this and he gets 1st place. So basically, as people get out, you put them at the end of the list. So if we were to rank, if we were to do our ranking, if we wanted 1st, 2nd, 3rd, and 4th, 1st place would be D because he didn't get out at all. The 2nd place would be A because he held strong in this election or competition till the very end and only got out at the last stage. Then C, and then B because B was the first one to get out. So under the plurality elimination method, the normal ranking would be like this, D, A, C, B. So we see that A has jumped to the 2nd place here, he's last here, and he's first here. So we're seeing there's lots of differences between these methods. So the last method we talked about in the previous video was the pairwise ranking method. So we're going to talk about we'll talk about the normal pairwise ranking method. So under this method, remember, we do each pair. So we have AB, AC, AD, then we have BC, BD, and then we have CD. And then we talk about who's the winner in each case if we were to just do a head-to-head competition between these. And all the data that we're using for all of this is coming from this table. So we find that between A and B, B would win, A and C, C would win, A and D, D would win, and so on. So who has the most wins here? We have C has 1, 2, 3 wins. So that means C has 3 wins. Then how many does B have? B has 2 wins, this one and this one. How many wins does D have? D has 1. And A has how many wins? 0. So since C has the most wins, we declared him to be the first place first, and B has the second most, so we put him in second place. D has the next most, so we put him as third, and then A has the least, so we put him as fourth. So A is again at the end of this list, and we can put a box around this to identify how we rank this. So now we're done. We used all 4 of our methods, and we just did natural extensions. This is why it's sometimes called normal rankings or natural rankings, because it's just the natural thing to do when you have this data. You just arrange it in terms of who has a higher number. So who has the most first place votes, who has the most Boorda points, who got out first, who got out last, and who has the most pairwise points right here. So just important things to note. So in all the red boxes is all the rankings. Here we have A, C, D, B. So A1 here. Here we have B, C, D, A, so B1 here. Here we have D, A, C, B, so D1 here. And here we have C, B, D, A, so C1 here. So despite all the orders of these people being different, one big thing to see is that the very big winner, the very top winner, the first place person is different in each case. Here it's A, here it's B, here it's D, and here it's C. So that's something about these methods. They're not always going to agree. They all have different ways of doing things, and that means you can find a very different winner and a very different list of first, second, third, and fourth in the end. So not to worry, these methods are not totally against each other. In fact, the real case is that this example I picked just to do this specifically, and you can see that because I put A in the beginning here, and I put A at the very end here, so that's kind of fishy. So usually in the real world, when you have real data, these methods will more or less agree and won't do something crazy like this. But this is possible. So this is the normal ranking methods, and on the back of this paper, we'll talk about the recursive ranking methods. These are a little bit more complicated, but we'll get the hang of it after we do one of them. So we did, on the back of this paper here, we did normal plurality ranking, where we just found the number of first place votes and we ranked them according to who had the most, who had the least. Now we can do the recursive plurality ranking method. This is a slightly different ranking method, but still involves plurality. So how do we do this? First, we find the person who had the most first place votes. We said that was A. Since he's the highest, he gets first place. So he's already in first place. He doesn't have to worry. We now remove him from our list. So that means everywhere you see an A, we basically just cross it out. And then we generate a new table. So how does a new table look? It looks like this old table with all the A's taken out. So it looks like this. We have first, second, third, and I just retain the B, C, D, all those people in this list. Now we find who's the highest of these people. We find it's B, because B has how many points? B has 15 and 5, or 20, and C has 11, or C has 13, and D has 9. So that means B has the most, so he is removed, and he gets second place. So this is called recursive because every time you find a winner, the next thing you do is you eliminate him. So a recursive pattern is something where the output of the previous step is the input of the next step. So since the output of the first step was A winning, that means the input of the next step is delete A. Since the output of this step is B winning, the input of the next step is going to be, you guessed it, you have to delete B. So now since B won here and he's entitled second place, we delete him from here and we just take this new list and we cross out all the B's and we generate a new list with just the C's and D's retained. So now that's here. Now the output of this is that C wins, because if we add up all the C's points, he's going to get more. So now we cross out all the C's. I mean, you don't really have to do this, but now that we do that, all that's left is D. So that means D gets fourth place. So this is recursive, and now it's a little bit different because what's the ranking in this case? Who got first place? A is still first place. Who got second place? B. Who got third place? C. And who got fourth place? D. So under the recursive plurality method, we have A, B, C, D as our ranking. So first, second, third, fourth. But under the natural or normal plurality ranking method, what did we have? We had A, C, D, B. Slightly different because B was actually last here, but B is actually second here. So this recursive method and the natural or normal method, these two different ways of ranking can differ as well. So I'm not going to go over all the other ones, it would take too long, but the idea is the same. So the recursive Boorda method, you find the Boorda counts, you take the first person out, so whoever has the highest Boorda total, in this case that was B, you eliminate him. So you get rid of him in all of this table, and you're left with a table with just A, C, and D. And now you find the Boorda counts again for A, C, and D, the new ones, and you find whoever's highest there. And whoever's highest of those is awarded second place. Then you get rid of that person, then you find it for the next two people, and so on. So that's Boorda. The recursive plurality elimination method is probably the longest one. To do this, you first have to do the first round of elimination. So on the back, if we see you do the first round of elimination, we see that D gets first place. So we take him out. Then we do the recursive we do the recursive plurality elimination ranking method again with just A, B, and C, and then we find who gets out, who wins in that one, and then that winner will get second place. So there's like two different kinds of elimination going on with this one. So this can get a little confusing. Make sure you keep your logic straight what you're doing. And the last one is the recursive pairwise ranking method. In this one, you find who's the winner of these pairs. So C would be the winner. Then you cross out all the C's in this table, so you're just left with A, B, and D, and then you do their recursive rankings. You do the pairwise for them. So luckily you're going to have less pairs because the people keep getting reduced to more and more. And then you do their pairs. You see whoever has the most points after that, they get second. You take them out. Then you do it for the next two people and so on until you have a ranking. So again, these methods, as I've noted down here in black, they may yield different results for second place and onward. The nice thing is that first place is always going to be the same, whether you do recursive rankings or whether you do natural or normal rankings. But second place and onward, there's no guarantees. They can be different. So the last thing I want to talk about to kind of wrap up this mini-series on voting is Arrow's impossibility theorem. So there's a very famous mathematician, economist called Kenneth Arrow, and what he found was that we have the four criterion we talked about in this mini-series: majority criterion, Condorcet criterion, monotonicity criterion, and independence of irrelevant alternatives criterion. We talked about them being they're kind of like gut feelings for fairness. We talk about how if there's a winner of an election, he should satisfy all of these criterion. Well, Arrow found that mathematically it's impossible to have all four of these criterion be satisfied, which is kind of perplexing but also interesting because it kind of says that there's no perfect democracy. You cannot have a perfect voting method where everything goes according to plan and everything satisfies all our gut feelings. And that even though that can be kind of frustrating, it's kind of elegant at the same time because there's always going to be flaws that we have to overcome. So hopefully this was a instructive mini-series, and we'll come back next time in the mini-series about power.